Again, good morning. Again, my name is Steve Price. I'm the General Manager of the Communications Infrastructure Division at Intel. The Intel team is here today and are excited about participating in 4G World again this year and look forward to meeting many of you during the rest of the week. I'd like to encourage the folks that have not attended the Intel booth yet to take a walk over and look at some of the demonstrations that we have for technology for today's networks, but also technology that I think will be required for future networks. And we have a bunch of our wireless team here today, our experts, that will be more than glad to entertain questions over there and answer whatever you might be curious about. You know, what an exciting time it is to be in communications. I mean, think about it. It's a changing time, a time of evolving technology. New devices and new services coming on board that's going to change the way that we work, we communicate, and the way we live. Before I get into the meat of my presentation today, I'd like to launch a short video to help better frame today's presentation and to underscore the possibilities of what's to come and the way it's going to change our lives. It's quite an inspiring video and depicts a future that's not that far away and all about what previous presenters have talked about, the individual quality of user experience. I know Intel believes in that vision, and I know many of the folks in this room also believe in that vision, are working hard to make sure that that vision becomes a reality by delivering the best applications and services, network infrastructure, and devices in the marketplace. Before I move on to the rest of the presentation, I would like to share a couple interesting factoids. In this year, in 2012, there'll be 2.7 zettabytes of data generated worldwide. And by 2015, there'll be zettabytes worth of data traversing the network. So how do we put that in perspective? What's a zettabyte? Well, to illustrate, I'd like to use the example of taking an 11-ounce coffee cup, and the volume in that coffee cup would represent 1 gigabyte worth of information. A zettabyte would be represented by the entire volume of the Great Wall of China. That's a lot of data. Or another way to look at it, 250 billion DVDs. Couple other interesting factoids. By 2015, there'll be twice as many intelligent connected devices to the network as there are people on the planet. And the amount of video being generated in 2015 to traverse the network, 1 internet minute would take an individual 5 years to view. So very clearly, there's great business opportunity to collaborate, but also challenges ahead of us to build out an infrastructure that really will meet the demands of the individual and users in general. Tectonic shift, geographical term that really means dramatic structural change or earth-changing transformation. We are putting forth a premise that most people agree with, that right now we're in a transformational stage. You know, at Intel, we often refer to and talk about Moore's Law. And when we do, we kind of restrict the conversation to process technology, the awesome aspect of process technology, which is pretty cool. But we also talk about miniaturization. And we get caught up thinking about how much more sophisticated computing and sensing capabilities we can put into devices around the world. But we often forget, when we talk about Moore's Law, another aspect that's in play. And that's all about driving down the cost of technology, the affordability of technology. I don't know if everyone realizes it, but we have already surpassed the economic threshold of compute and communications where it's near pervasive. Just look around this audience. Look at the number of tablets and laptops and smartphones that are here today. Look at what they're connected to and the build-out of networking, wireless networking in particular. At Intel, we truly do believe we're in the midst of transformation. And there are 4 major trends in technology, and I'm sure there are others that we would like to talk about, that we believe will change the very way that it transforms services that are made available and the way that we live and the way we work. Kind of like what that video was talking about or referring to. And those 4 transformational trends that we see, the Internet of Things, or IoT, big data, cloud computing, and services evolution that are tailored services for the individual or the individual subscriber. So the first industry shift that we would like to speak to is IoT, or the Internet of Things. By 2015 or so, there'll be 15 billion, at least 15 billion intelligent connected devices to the network, which represents about a $2 trillion market opportunity for intelligent systems. You know, the thought of connecting devices to the network is nothing new. M2M has been around for years. And the concept of RFID is at least a decade old. But what is new, what has changed, is wireless communications is nearly pervasive. And that really matters. The economic boundaries, barriers, are falling away due to Moore's Law. The industry of M2M is morphing into the Internet of Things. That is a world filled full of intelligent, connected devices that are connected in a secure way. And the evolution of the embedded device itself is no longer just a connected device, simple data gatherer. It's transforming to an intelligent device that analyzes, perceiving through context awareness, and eventually will make proactive decisions on where that data goes, what it does, and how it interacts with the network. The most exciting aspect of this, yeah, it's awesome technology. We're all working on stuff that is really, really, really cool. And it will, in fact, drive the economies of deploying new networks in the right direction, being much more efficient from a bit perspective. But really, the innovation will be around new services and new business models, and the opportunity for this industry to really collaborate and figure out how we improve that user experience, our experience, both in our private life and in business, while also, as an industry, making money. You know, when we think about what to connect, or what kind of services to create, or how to create business models, you're limited by two things: our own creativity and the willingness for this industry to collaborate to bring the next generation of digital world. The second thing I want to talk about is big data. With so many intelligent devices being connected to the network, they're also generating an awful lot of data, tremendous amounts of data. And when we speak about data, we like to speak in terms of volume, velocity, variety, and value. So volume is what it implies. It's how much data is out there. Velocity is about not only how much data, but how fast that data is growing and how we're able to process that data. Today, only 15% of the data that's created is actually harvested and analyzed. The rest of it is either stored or, in fact, discarded completely. So that's all about volume, or velocity, excuse me. Variety. You can see on the chart here, when we think about variety, we think about the different types of data. And we'll only talk about really two here, structured and unstructured data. And you can see the growth of structured data is very manageable, but it's the unstructured data that creates both challenges and tremendous business opportunity for all of us. Companies will need to deal with 50x more data by the year 2020. So what is this unstructured data? Well, unstructured data is data that is not in a relational database, so that's structured data, or Excel spreadsheets, that's structured data. It's data that's being generated by sensors, by cameras, by devices of all size, shapes, and types. It comes in the form of video, it comes in the form of photographs, IMs, text messages, Word documents. You kind of get it, it goes on and on. And the interesting part about unstructured data is it has a tremendous amount of value. The challenge is how you analyze that data, how you analyze it in real time and do something with it, either discard it, store it, or monetize it in some way. So that's variety. And last is value. Data turned into information is valuable, but how do you sort through that zettabyte worth of data out in that 2015 timeframe coming across the network? Somehow you have to filter it and analyze it in order for it to become useful. You know, to illustrate this point, and I won't belabor it much at all, I'll just touch upon this, is there is an initiative in China going on called the Smart City. And part of that Smart City initiative is a traffic congestion management system. Now, the intent of this system is to improve traffic flows in a congested city. And the data generated within that network itself comes from a variety of devices that are deployed over, I think, 1,000 square kilometers area. It's 500,000 different devices of cameras and sensors and smog detectors and so forth and so on, motion sensors for traffic flow, so forth and so on, that when brought together generate over 200 petabytes of data. That's a lot of data in a single month, that is. So that's not per day or per year, but per month. Now, what you do with that data and how fast you react to that data is really ultimately how useful this whole system is going to be. Now again, it's a smart city and it's in different phases, so forth and so on. But really, the time-critical data that's being used, it's going to be used to control traffic lights as an example. And it's going to help determine how traffic will flow. So if it's taken data, for instance, and it's looking at the traffic patterns and how many miles per hour or kilometers the cars are moving, and how much smog or air quality decrease is occurring, it takes a look at all that information. Might it be by video? Might it be by sensors themselves? And makes a calculation and determines how the traffic should flow. This data is also being collected and being used not at real time, but critical time elements to manage streetlights for safety. Also, the cameras are used for pedestrian safety or identifying accidents or road hazards or whatever the case might be. So they can take that information and then adjust accordingly so they can reroute the public traffic and, in case of the emergency, the appropriate path for emergency vehicles. So that's kind of the lay of the land and what they're doing with that data for the principal use. But there is also a secondary use, because once you've harvested that data, once you've analyzed it, tagged it, and stored it, it becomes valuable to others. And now they're looking at ways on how good the government can use the data, private industry can use the data to create new applications and services that create new revenue streams targeted, of course, at the consumer. The next major change in the market, this shift, is cloud networking. Now, a lot's been said about cloud networking, so what am I going to say about it that you already don't know? Probably not much. But there's a desire here in the market to move to network as a service, kind of on demand. And whether it comes from a private, public, or hybrid or cloud-hosted model really isn't relevant. If you kind of look up at the screen here and you see the growth required for the network, for storage, and for compute, we're talking about 8x, 16x, and 20x capacity requirements in the very near future. That's only 2 or 3 years away. So very clearly, lots of growth going on, lots of challenges, and lots of opportunity here. You know, as the rise of the network as a service occurs, it's going to require significant changes to the network architect itself, the existing architecture, where traffic will need to be dealt with in a much more intelligent way, resulting in better efficiencies of both the edge and cloud assets that are being deployed. Verizon has presently begun to explore how to use data center capabilities and SDN technologies together, so to see if they can alleviate some of the cost and scaling challenges that have created the inefficiencies of rolling out traditional networks. Working collaboratively with HP and Intel, they're now beginning to examine carrier-centric cases that might take advantage of software-defined networks. So let's just touch base quickly on some of the technologies associated with next-generation networks. Now, I'm only going to talk about 4 of them. and there are many others, but COTS-based solution coming from the data center, virtualizing the network. There's also the orchestration layer that's required for SDN networks. And we'll talk about application and services aware solutions. So in the case of COTS-based solutions, what they learned in the data center, we now know that we can bring Moore's law also to the network itself. And what does that mean? What that means is you'll be able to deploy much more quickly capacity, applications, and services at rates that we've never seen before in the edge or the cloud side of the network itself. Virtualizing the network. Well, what does that do? Well, it does a lot of things, but one thing that's very powerful is it creates a sea of computing platforms or processing units that can be used in many, many different ways and is excellent to support highly volatile, dynamic environments with ever-changing workloads and new workload demands. And what that does is it allows you to take the assets that are deployed in the cloud and edge and reapply them to wherever you need them, whenever you need them, real time, automatically. Orchestration layer. The orchestration layer is really pivotal. It's crucial to the concept of software-defined networks because it creates this seamless coordination and interaction between the device, the edge, and the cloud network itself. An application and services-aware routing, when combined with OpenFlow, another important technology of software-defined networks, will enable a technique to route traffic called traffic steering, which will, in fact, make much better use of your network assets and also enable the concept of subscriber-tuned or tailored services for the individual. You know, at the end of the day, there's a lot of stuff that has to happen with SDN, but the goal of SDN is to create this seamless environment, the interaction between the device, the edge, and the cloud, where we enable new services, for sure, new application, but more importantly, new business models, while also driving the efficiency of the network up, network deployment, in other words, driving down the cost per bit of deployment and improving the overall profit of the model itself. This leads us to the fourth major shift. So I talked about the awesomeness of the network, what has to happen, what we're doing there. You know, it's interesting, when we start talking about the evolution of services, services tailored for the specific subscriber, we saw some of the examples of that in the video earlier today. And that video depicted, you know, the life of a subscriber, its usages in a connected world. And as you watch the video, I can't imagine, but some of you must have thought about the critical role that the edge, the cloud, and the back-end services provide. I mean, after all, what we're working on actually brings that vision to life. It's all about the network. Okay, so then why the emphasis on the evolution of services tailored toward the individual? Why is that so important? Well, because it creates new ways to interact, to reach customers, to create new services, and at the end of the day, generate new revenue streams, which is critically important. It drives demand between business and consumer, you know, B2C. Even the business user is expecting, no, the business user is demanding now the same kind of user experience that they've had in their private life in their business life. They see the productivity that has been gained in their private life and want to transfer that over, reaching new higher levels of productivity and innovation within the workplace that will cause an entire workplace transformation. You know, CEOs are facing this now every day. They see the realities, the requirements to deliver an awesome quality of experience. And the reason why is because they truly do believe it's going to drive up productivity in the company. But they also need to do it in a way that they achieve other business metrics as well, like delivering a trusted, secure network within a cost and affordability model. You know, as an industry, we have a lot of the key building blocks in place to create this next generation cloud and support these new services that are tailored for the individual subscriber. However, there are technical gaps, challenges to meet that need to be addressed. But that being said, the new horizons and opportunities are boundless. You know, the possibilities are endless and exciting. But there are further optimizations required to make sure that we can dynamically manage these virtual resources that I've been talking about, and to ensure that the SDN technologies can scale to the breadth of what the telecommunication networks really, really need. So I'll mention 5 examples of technology challenges, and there are many, by the way, but these are the 5 that I chose to speak to today. It's energy efficiency, trust and security of the network itself, the user experience, data, and then management and automation. So energy efficiency. You know, the cost of energy is going up all the time, and the trend longer term will be, it will be going up rather than going down. And there's pressure throughout the world by government agencies as well as environmental agencies for us as consumers to be much more conservative and be power friendly. That's also placed on businesses as well. You know, one of the major factors of the equation to make money with the operators and service providers is their operation cost. So they have CapEx and OpEx, and a major portion of the OpEx is managing the network and energy. So any future generation of network will require energy-sensitive, energy-friendly architectures. And technologies like power management and the application of Moore's Law that drives up compute power and reduces overall energy power is critically important. Trust and security. So again, we've talking about this on-demand network as a service, and that's great. But there's a growing concern about trust and security and the protection of privacy and data set and privacy, where these data sets and workloads are becoming dynamic and are virtualized. In addition, in the beginning of my presentation, I talked about all those intelligent connected devices, which are absolutely a great business opportunity for all of us. But it also creates new challenges when it comes to security. The growing number of devices connected to the network will increase the opportunity for online fraud and even cyber terrorism. The user experience. The user experience is king. I don't know about where you work, but I know where I work. What IT says is what I get. And in the new world, that will change. In the new world, we become consumers. And consumers have choices. And the IT manager realizes, again, that there's an awesome opportunity here to make everyone that works in that company more productive by creating this unbelievable user experience and take advantage of many things that are happening already as a private subscriber. But they have to make sure that they do this in such a way that they don't compromise the previous bullet, and that's security and trusted networks. Data, we've talked about a lot. The challenge for data in a nutshell is it's growing so fast, it has so much value associated that it's going to create significant headaches on how to process that data, harvest that data, send it to the appropriate application or server of some kind to create some kind of utility. And last but not least, management and automation. Given these new scales of the infrastructure and also the number of devices coming online, new users, and new services, we need to figure out ways to automate the management of these networks to keep the cost structure economical. So to wrap things up, and this is my final pitch, is I want to reiterate that, you know, we are seeing tectonic shift throughout the industry here, and opportunities are won and lost during times of transition. Everything I talked about today is about the intelligent interaction of devices to the edge, to the cloud network itself, which will create new services, but even more importantly, spawn new business models. It's all about harvesting the data that's been created by the sea of intelligent devices connected to the network, and to be able to figure out how to use that data. Our ability to capitalize in this market, to take advantage of this evolution, to harvest the business rewards themselves, will be dictated by how fast we as an industry embrace standardization and new collaborative models to increase the velocity of building out this next generation of network services. You know, there's been a lot of progress made since the last 4G world where we did a keynote. A lot of development of applications and next generation cloud technology. But there's a lot more that still needs to be done to move these services of the future from a nascent kind of implementation niche to really mainstream deployment. And yes, it's about collaborating from a technology perspective, but even more importantly, we need to find collaborative business models to move this ball forward more quickly. So I want to thank you all for attending this keynote today, and I wish you all a really good 4G world. Please stop by the booth, see what we're doing, talk to our wireless experts, and again, thank you for your time.
And Steve, I think we got your message very clearly that the Intel group is very happy to take questions and show the demos and expose all this information at your booth. And the show floor is now open, so we're going to send everybody over there if you don't mind.
No, that would be great. And again, thanks. I know it was before lunch and everyone was pretty patient, so thank you.